Welcome to another session of Strategic Financial Management. Today we are going to discuss about Module 3, Long-Term Investment Decisions. At the end of this session, you will be able to understand decision tree analysis and its practical problems. We are discussing about capital budgeting techniques. Decision tree analysis is a quantitative technique, and the decision tree analysis is a technique of solving decision-making problems by mapping out all feasible alternative actions, assigning respective weight, and evaluating the net effect on the different actions at a starting point. And it is a graphical display of relationship between a present decision and a possible future event, and future decision and their consequences. We can see what are the procedure of preparation of decision tree. It has got two components, decision tree points and chance point, represented by square boxes and circle respectively, which means decision points are represented by square boxes and chance points are represented by circles. Probabilities are assigned to each future uncertain events, and decision tree diagram is drawn from left to right. Each alternative is evaluated using a weight or probabilities by backward induction or rolling back procedure. And the alternative with the highest net present value is chosen at every decision point. We can discuss a problem relating to decision tree analysis. A firm wants to acquire new plant which require cash outlay of rupees 10 lakh. The useful life of the plant is 2 years, but there will be no salvage value. Year 1, there are 3 events, event 1, event 2 and event 3. And the cash flows will be 4 lakh, 5 lakh 50,000, 7 lakh 50,000. And the probability will be 0.3, 0.4 and 0.3. In year 2, cash flows and probability are also given. Rupees 4 lakh in first year, then in second year, there is a probability of 2 lakh 0.2, 5 lakh 0.6 and 7 lakh 50.2. And if in the first year the cash flow will be 5 lakh 50,000, in the second year cash flow will be 6 lakh 50,000, 7 lakh 50,000 and 8 lakh with a probability of 0.3, 0.4 and 0.3. If in the first year cash flow will be 7 lakh 50,000 and in the second year cash flow will be 8 lakh, 10 lakh, 12 lakh and probability will be 0.1, 0.8 and 0.1. The cost of capital is 10%. Plot the above data in the form of a decision tree and advise whether the project should be accepted or rejected. We can draw a decision tree. First of all, we should show the cash outlay of the project, that is initial cost of the project, that will be 10 lakh. And the probability of cash flow in the first year is also given in the question. It will be 0.3. Then the cash flow will be 4 lakh. If the probability will be 0.4, cash flow will be 5 lakh 50,000 and the probability will be 0.3, cash flow will be 7 lakh 50,000. Then if the cash flow in the first year will be 4 lakh, the cash flow in the second year, there is a probability of 0.2 and the cash flow will be 2 lakh and 0.6 cash flow will be 5 lakh and 0.2 cash flow will be 7 lakh 50,000. If cash flow in the first year will be 5 lakh 50,000, the cash flow in the second year will be 0.3 and the cash flow is 6 lakh 50,000, 0.4 7 lakh 50,000 and 0.3 8 lakh. If cash flow in the first year will be 7 lakh 50,000 and the cash flow in the second year will be 0.1 and the cash flow is 8 lakh, 0.8 10 lakh and 0.1 12 lakh. Next we can prepare a working note for calculating net present value. Year 1, there are 3 chances. First chance will be 4 lakh, second chance will be 5 lakh 50,000 and third chance will be 7 lakh 50,000. But in case of year 2, there are 3 chances for each of the options. So we can calculate the present value of each of the option. Suppose cash flow of the year 1 will be 4 lakh and the year 2 will be 2 lakh. Cash flow in second chance, that is 4 lakh, then cash flow in the year 2 will be 5 lakh. If 4 lakh, then 7 lakh 50,000. Like that, cash flow for the first year 5 lakh 50,000, second year sometimes it may be 6 lakh 50,000, then cash flow 5 lakh 50,000, sometimes cash flow in the second year will be 7 lakh 50,000 like that. Sometimes it may be 8 lakh. If cash flow in the first year 7,50,000, cash flow in the second year will be 8 lakh, 10 lakh, or it may be 12 lakh. Next, we can calculate present value of cash flow of each of the year. From the question, it is clear that the cost of capital is 10%, so that the present value factor for the first year will be 0.909. In order to calculate the present value of year 1, the cash flow of the year 1 will be 4 lakh. So, 4 lakh into 0.909, it will be 3,63,600. Again, 4 lakh into 0.909, it is 3,63,600. Again, it is also 3,63,600. In year 1, the cash flow sometimes may be 5,50,000. So, 5,50,000 into 0.909, it will be 5 lakh. Again 5 lakh, and the third chance it's also 5 lakh. But in case of third trial, it will be 7,50,000. So, 7,50,000 into 0.909, it will be 6,81,800. Again 6,81,800 and 6,81,800. Like that, present value factor of year 2 will be calculated. From the question, it is clear that the cost of capital is 10%. So, present value factor of the second year will be 0.826. Next, we can calculate present value of year 2. Cash flow of year 2 will be 2 lakh. So, calculating the present value of year 2, 2 lakh into 0.826. It will be 1,65,200. Then again 5 lakh into 0.826, 4,13,000. Then 7,50,000 into 0.826, it is 6,19,500. Then second trial, 6,50,000 into 0.826, 5,36,900. Then 7,50,000 into 0.826, 6,19,500. 8 lakh into 0.826, 6,60,800. Then 8 lakh into 0.826, 6,60,800. 10 lakh into 0.826, 8,26,000. Then 12 lakh into 0.826, 9,91,200. Next, we should take the total of present value of year 1 and year 2, which means 3,63,600 plus 1,65,200, it will be 5,28,800. Next, 3,63,600 plus 4,13,000, it will be 7,76,600. Then 3,63,600 plus 6,19,500, it will be 9,83,100. 5 lakh plus 5,36,900, it will be 10,36,900. And 5 lakh plus 6,19,500, it will be 11,19,500. Next, 5 lakh plus 6,60,800 equals 11,60,800. And 6,81,800 plus 6,60,800 equal 13,42,600. And 6,81,800 plus 8,26,000 equals 15,07,800. 6,81,800 plus 9,91,200, it will be 16,73,000. Next, we can calculate net present value. The formula for the calculation of net present value will be cash inflow minus total cost of the project. Cost of the project will be 10 lakh. So, total inflow will be 5,28,800. So, 5,28,800 minus 10 lakh, it is negative 4,71,200. And in the second option, 7,76,600 minus 10 lakh, it will be minus 2,23,400. In the third option, 9,83,100 minus 10 lakh, it will be minus 16,900. And 10 lakh 36,900 minus 10 lakh, it will be 36,900. 11 lakh 19,500 minus 10 lakh will be 1 lakh 19,500. 11 lakh 60,800 minus 10 lakh will be 1 lakh 60,800. 13 lakh 42,600 minus 10 lakh will be 3 lakh 42,600. And 15 lakh 7,800 minus 10 lakh will be 5 lakh 7,800. And 16 lakh 73,000 minus 10 lakh will be 6 lakh 73,000. From the table, it is clear that the net present value of the first option will be negative. Next, we can write already calculated net present value in the decision tree. In the first option, it will be minus 4,71,200, and second option, it will be 2,23,400 and 16,900, 36,900, 1,19,500, 1,60,800, 3,42,600, 5,07,800 and 6,73,000. Next, we can calculate joint probability. In the first option, probability of getting rupees 4 lakh as cash inflow will be 0.3, and for getting 2 lakh rupees cash flow in the second year will be 0.2. So, for calculating joint probability, we should multiply 0.3 and 0.2. So, 0.3 into 0.2, it will be 0.06. Then 0.3 into 0.6, 0.18, 0.3 into 0.2, 0.06. And in case of second chance, the probability of getting rupees 5,50,000 will be 0.4. And the probability of getting 6,50,000 will be 0.3. So, 0.4 into 0.3, 0.12. Then 0.4 into 0.4, 0.16. 0.4 into 0.3, 0.12. And the probability of getting rupees 7,50,000 will be 0.3, and the probability of getting 8 lakh will be 0.1. So, 0.3 into 0.1, 0.03, then 0.3 into 0.8, 0.24, 0.3 into 0.1, 0.03. The total of joint probability will be 1. Next, we can calculate expected net present value. For calculating expected net present value, we should multiply net present value and joint probability. So, 4,71,200 into 0.06, 28,300. 2,23,400 into 0.18, 40,200. 16,900 into 0.06, 1,000. 36,900 into 0.12, 4,400. 1,19,500 into 0.16, 19,100. 1,60,800 into 0.12, 19,300. 3,42,600 into 0.03, 10,300. Then 5,07,800 into 0.24, 1,21,900. Then 6,73,000 into 0.03, 20,200. The total of expected net present value will be 1,25,700. So that we can conclude that since the expected net present value is positive, the plan can be acquired. In this session, we have learned about decision tree analysis and its practical problems. I think everyone has understood the topic we have discussed today. Studying more practical problems will help you to understand the problems very quickly. Thank you.